So I'm going to be covering today about default tolerant service, which Charles introduced earlier. So this is part of this is the first solution that we are bringing with the big memory cloud. So let's go over and forward, not backward. So I want to start off with the state of the cloud, right? So when I talk about cloud spending is on the rise, you guys are all reading the news articles are coming out. All the cloud vendors are having blockbuster years so far. According to this TechCrunch article, it's $180 billion have been spent in Q3 run rate business. And Gartner predicts there's a 23% growth over last year to almost 323 billion, the exact number actually. I quoted from one of the reports there. So this is including all the PaaS and all the X as a service kind of thing, right? So money has been spent on cloud, and another recent poll by Gartner suggests that in the last year, the uptick has been phenomenal. Half of the cloud spending, cloud vendors who were polled, they said they've gone up by 20%. So already now they're spending 20% more. So this is happening. And at some point, the IT administrators are going to, the CIO is going to be getting a call from the CFO like, hey, man, what's going on here? You're spending a lot. Like, yeah, I'm delivering a lot, so I'm spending a lot. So that conversation is going to happen. And, to avoid, obviously, not everybody has to. Okay, hold on a second. My thing froze up here. Are you able to see it? Okay, cool. So where I'm going with this story is the cloud spending can't go on infinitely from a customer perspective, right? So there has to be some way of cutting down the cost. There's a point of time where you have to start thinking of how do I save some money for my company? Most cloud vendors, all the public cloud major vendors have some way of introducing spot services. Google calls it preemptive VM instance, Amazon calls it spot instance, and Azure calls it spot VM. So what are these spot instances? Let's take example of AWS. So in AWS, the spot instance or the excessive build or spare capacity that EC2 has for people to use. So what they do is they give that as a huge discount because they don't want to just keep these data centers running, heating and power and all cooling and power and all that will be used, right? So they want to give you steep discount to give you this spot instance, and it's much less than what you're going to pay for on-demand prices. So that's one thing. And all of these things are geared towards giving you lower cost, and this cost is actually significantly less. We're talking about 80 to 90% less cost. And the way they determine the spot prices, that's a PhD. You can do a PhD on that. A lot of people have done research on that. But I'm not going to go into that detail. But the spot instances are much, much cheaper than the normal on-demand or even private pricing or the other savings plan that you have signed up as a customer. But the problem with this is if spot instances are so cheap, why aren't people using it, and why not all workloads take advantage of this? The challenge with this is the spot instances are not suitable for stateful, long-running, and fault-intolerant or non-fault tolerant workloads. And also workloads that have, HPC workloads where you have node-to-node communications are happening, and you can't completely capture the entire state of the application. So no wonder it's not being talked about. I talk to a lot of customers, and they say, "I've never heard of spot instance. We never use it." That sort of thing, right? So there's the reason why people are not doing it. And when we talk about some of the applications that we are very successful in, like the AML training or the CAD simulation workloads, or even movie rendering, and last but not least, the genome sequencing. These are long-running jobs, and sometimes they take days, sometimes they take weeks, and they're stateful jobs. So these jobs cannot be run on the spot instance, and that's why a lot of people are like shying away from those things. So if I really look at slide on the spot savings. You go to Amazon's website. I take an example of AWS website here. If you go to the website, every instance is up for grabs from a spot instance perspective. So this is just an example I took last week. as you see here, the range is from 80 to 90% savings. And this is great, right? So you instead of paying on-demand pricing of full price, you're getting huge amount of discount here. And the thing in red is probably people are not using it because the interruption rates are also pretty high. Like some instances are interrupted like 20% of the time. So the interruptions comes in like a notification saying that, hey, in the next 30 to 2 minutes, I'm going to take away your instance. So if you're running some long-running jobs, you're ending up going back and rerunning all over again. So that's why not many people are running this in the data center. So we already touched on this, why nobody taking advantage of it. That's why we come into play here. So if you followed the first session with Charles, you will see he introduced the app Capsule. So we have used the technology that we have built over past years, and we are kind of implementing in the cloud. So let me kind of set the stage here. The yellow boxes are the cloud services provided by the cloud vendor. In this case, it's AWS. You have a cloud management console, you have the services. The orange boxes are the user side. The user or the customer has an application that he or she wants to run, and there's a job scheduler they're already using. And the boxes in blue is our technology, the fault tolerant service management center, and the fault tolerant service agent. So the way it works is we will deploy, our management center will deploy our AMI or AMI as you prefer, and you would run our memory machine in that VM or a container, and you would keep running. You get a notification. Then we will move we are periodically taking these snapshots, and we will move when we get the notification. I will go into the detail a little more, but I want to give you an idea, like the blue boxes are our secret sauce. Those are our IP, and all the transition that happens underneath the covers is our IP, which we already demonstrated in the last field day as well. And so if you really want to go through step by step, this is how it happens. Let it build out here quickly. So we have installed the AMI in the VM or container, and we have started running the application. The application has a bunch of state, right? There's not only as Enrico was asking earlier, it's not just the memory state, it's the L1, L2K state, all the other register states in the memory, and then also the files that the application has opened in the storage, right? So there are a bunch of files and sockets and all the stuff that comprise of the state. We take periodic frequent snapshot. It can be a duration up to three minutes. Or it can be 10 minutes based on your application. In this case, we will take periodically about 2 minutes, and we will save that on to the memory and slowly write it to S3 disk as well. So in step 3, once your spot notification, we get the spot notification, our management center will say, okay, now it's time for me to go get a new spot instance allocated, and start to restore and resume my application in step 5. So this step 2 to step 5 is fully automated, and you don't have to know about it. And we will make sure that the application starts off from where the last snapshot was taken, and it runs as though no interruption has happened. So that is the key of this technology. And we have built this over a few months already, and we have some customers using as well. So what I'm going to do is I'm going to take you through some of the cool use cases that we've got early access into, and I will take you through some of the cost savings in those things.
One question I've got: your step 2 there, it shows the snapshots landing into S3. Is that very specific S3, or is that anything that's using the S3 compatible protocols?
In this AWS example, it's a normal S3 bucket.
Okay.
So that's we create a bucket and we just put the file.
But I mean, AWS S3 or Azure Blob or
yeah.
Okay.
We're going to work with Azure Blob, and Azure's support is there, and GCP storage as well. So, yeah.
Okay. Yeah. What about if you're starting? I guess your beginning place is on-prem or something that's not, quote unquote native cloud, but also has access to S3 or S3 compatible object storage. Is that also supported?
So that's a very good question. So you're a hybrid model, you have an online on-premises application, you want to send it to the cloud. That's actually possible. I think Eric is going to do a little demonstration of that. So I'm not going to steal his thunder. So you can see that in action. Yeah.
Sorry, it's Enrico.
Yeah.
I didn't understand. Do you have an orchestration layer that manages? Think about several instances, not just one, and I have to keep a state of everything and then manage. So the FTS management center is actually an orchestrator that you manage.
So the FTS management center is our management center that makes sure the application snapshots have been taken, and it kind of receives a notification, does the processing. So we will work with your job scheduler if you have one, or we will provide you one if you don't already have one. So you're running a multi-stage pipeline and you have a job scheduler to do that. So we can either integrate with that or we can provide you one. And so the orchestrator also, we will provide you orchestrator integration also. We don't really have an orchestrator per se. I think it's time to kind of go through the actual results that we are seeing for our fault-tolerant service. And one of the things that have been successful in the vertical is the genomics vertical. And genomic vertical, there are lots of gene sequencing programs. Here, this one is a de novo gene sequencing assembly pipelines. These pipelines are actually very well suited for our product because these are long running. This one takes like 10 hours, and it uses a lot of DRAM. Here it takes almost 1.5 terabytes of DRAM. And the AWS instance that the customer was using was a X1E 16S large, which is like really huge. It's 32 CPUs, 1.5 or more terabytes of memory, and it costs a lot of money. When you go on demand, it costs around $13 per hour. But the same instance is available in Spot at a 70% discount when we are doing this test. And the interruption rate was pretty high. The customer would never run this in a Spot instance. So like, no way they're going to do this because this is life-saving gene sequencing stuff. They don't want to take anything for chance, right? So enter fault-tolerant service from MemVerge. We will use the Spot instance, and we would run for 10 hours by moving from one Spot instance to another Spot instance. And with the overhead cost that we have, plus the Spot instance cost, we are like $48. And the savings is like 63%. So this is an example of how a long-running stateful job is being run with our technology, with this kind of savings for your end customer. So this is pretty amazing. And when we start looking at, hey, this is a sweet spot for us, let's go and look at other genomics companies who are doing this. So of course, more companies are coming online with their own proprietary, their own way of doing things. Here is another company which is doing plant drive. This is for most like a plant genome analysis. They take 3 weeks to run a single job. This is massive amount of processing, and they were running on their own data center because they couldn't afford to run in Amazon for the longest time. Maybe some grant money they got, and they said, okay, let's run it on X1E 8X large, and it's almost like a terabyte of memory, and it takes a lot of money to run per hour. For them, the savings are around 64%, because with our cost was around $1,000 plus, the real on-demand cost was around $3,000. So again, what they weren't able to do before, they're able to do now at like 64% less. So I have one more example of this, and I will take you to another different altogether. So this is another, Splatter is a very famous, very popular RNA splicing analysis code. And this one runs for like 2+ weeks. So the instance we are talking is an R5D 16X large. Again, it has 512 gigs of memory, lots of cores. It there's a lot of computation. This is a 64 core instance here. And this one has a 85% spot discount. This is pretty awesome, right? So why pay full price when you're getting this discount? And this one has the most saving because it runs for the longest time. So the longer running jobs have a highest advantage of getting the most benefit with our technology. So, and these early access customers have been helping us to get more of these genomic customers. And we are having a very sweet spot around genomics as a general use case, apart from the AI ML that is still undergoing POC at this time. So that said, the last one, but not the least, is the animation, right? Everybody these days are making animation movies, and animation rendering is a big business. And most of these things take a huge amount of time. I was talking to one of my friends who is in this business, and they say they run for weeks, and there'll be like, black spots everywhere, and they have to rerun the task or try to process that small spot. And it's like pulling hairs to just process the things that are missed out. So what they do is they rerun the whole task. So again, you got to spend $1 per hour, and you got to spend a lot of money. So here, what we do is we check out a spot instance and keep the rendering going for as many days as you want, and you get another 61% of savings. So that's sort of the things we have seen so far.
Yeah, I have a question. If you have instead of a single instance, multiple instances that are connected somehow in a cluster fashion, you can use your technology, because in the time you take the snapshot, you save a copy, and then you start a different spot instance. That particular node is is considered failed, so you can't re-import the node in the cluster, right?
So great question, Enrico. We have been doing, I think Charles alluded in the previous presentation, in a Kubernetes cluster, we are able to take a pod level snapshot using Creo, and also enhancements on top of Creo that we have our own IP on top of it. So that would enable freezing the entire cluster state and actually flushing it out so that you can restart the entire cluster elsewhere. So that is the really cool technology. And as Charles was alluding, we will probably have another field day to demonstrate that, so that it'll be more focused on containers and Kubernetes and that sort of thing. Does it answer your question, Enrico?
Yeah, thank you.
Cool. Okay. So, not to take more time from Yong, he has much more meaty stuff. He's going to go deep into the technology. From my presentation, I think the key takeaways is we have built a technology that encapsulates the app capsulator really encapsulate all the states of the application so that it can be snapshotted and restarted somewhere else. And by using spot instances, we are providing a way to save money when you're trying to move all your applications to the cloud. And you obviously, money is not free, right? You want to save money. We're going to give that. Significant cost reduction is what we are promising. As you see in the examples, there are 60 to 70% reduction. And then call for action sort of thing is, we have early access program right now. GA is coming sooner in Q1 2002. Our product will be available in AWS Marketplace. We have set the ball in motion. Anytime soon, we'll have that available. Pricing will also be announced in GA. Nothing surprising there. And if you need more contact, you can contact our SDR and the information there.